Hello, I'm Ugen Lhamo, and today I'll be presenting on the evaluation of atmospheric exposure test on structural steel and hot-dip galvanized steel in the eastern part of Thailand. So for the table of content, firstly for the overview, which is overview, so introduction, then methodology, research results and discussion, conclusion and reference. For introduction, we have the definition. What is steel corrosion? Steel corrosion is irreversible deterioration of the steel's material and the vital properties due to the chemical reaction with the environmental factors. As we know that the consumption of steel is uh, increasing every day, and in the survey conducted by the OIE in 2020 by Thailand, it was said that the expansion of the construction industry will increase by 5%. Therefore, if you are able to maintain the steel, uh, it will be of much help. So therefore, as we know, the main shortcoming for steel is corrosion. Therefore, as we cannot prevent corrosion, we can minimize it by applying a very adequate protection. And to apply the adequate protection, as we know, the rate of steel of corrosion depends on the environment the steel is in and the type of protection it needs to be applied. Therefore, with the adequate protection, we will be able to save the structure's durability as well as extend the service life. Now, moving to the problem statement, uh, the main problem is that in Thailand, they do not have a specific steel corrosion standard, and the studies that have done in steel corrosion are very less. So this research is to help contribute to the development of the steel corrosion manual, as well as more information on the steel corrosion in Thailand. So my main objective for this research is to gather more knowledge about the coated steel for the Thai structural steel industry, to know the importance about galvanizing, and to compare the uncoated and hot dip galvanized. All this will help in the material selection as well as contribute to the development of steel corrosion manual. So for the scope, the type of steel we will be using are carbon steel, and then there are two types, that is SS400 and SM490. The area of study is in the eastern part of the eastern part of Thailand. So there are three locations, and mainly two provinces, that is Chachoengsao and Chonburi. In Chachoengsao we have Union, and in Chonburi we have Kotko and Centurion Eastern Galvanized. And the standard that we will be following in this research is ASTM standard and ISO standard. So for the methodology, for the overview, firstly, we have three stages: exposure, collecting and analyzing. In exposure, we prepare the specimens and collect the data. We prepare the data for collecting the environmental data as well, and then expose it. In the collecting data stage, we collect the data from the exposed specimens, and then in the analyzing data, we calculate the corrosion rate. Now moving to the first part, that is exposure stage. For the specimen, we have the properties. The standard we follow is ASTM G92, and the dimension is 100 times 150 times 4.5, that is all in millimeter, and the period of exposure is 3 months and 6 months. Like I said before, it is two types of steel, SS400 and SM490. The figure 1 and 2 are the examples of how the steel structure looks, and the table given below here is the chemical composition of the steel structure of the two types of steel. So, following the ASTM G1 and ASTM G31, we prepare the specimens. For bare steel, we follow the ASTM G1, and for the hot dip galvanized preparation, we follow the ASTM G31. And these are the steps. So, firstly, we sandblast. For bare steel, we sandblast. Then use sandpaper to smoothen. Then we mark the specimen to be able to identify, and then we measure the dimensions: 3 times for the height, 3 times for the length, and 8 points for the thickness. And then we clean it with DI water, and then we dry with the air dryer. And then after that, we weigh the specimen, and then we store it in the desiccator, and then send it to the station that we require. So we do the same for the hot dip galvanized preparation as well. Now moving on to the environmental data, for the atmospheric parameters that we collect are the temperature, rainfall, and humidity. These are the instruments that we use for the atmospheric parameters to collect the atmospheric parameters, and the data is directly sent to the weather underground. So for the arrangement of exposure stage, exposing to the real environment, we expose in some areas we have one rack and in some areas we have two racks. So depending on that arrangement, we arrange the specimens in this way. And for the environmental condition, this is how the station would look uh, after exposing. Now for collecting data stage, we collect two specimens for bare steel, as you can see, and then three specimens for hot-dip galvanized. So to remove the bare steel, after collecting the bare steel, we remove the corrosion by following the ASTM G1 table A1.1 C 3.5 standard, and then for the hot-dip galvanized, we again use the same standard ASTM G1 table A1.1, but we use C 9.3. Now we are in the analyzing stage. So for the analyzing stage, we follow the ASTM G1 standard as well again, and then we plot the graphs and we use the equation to calculate the thickness loss. So while calculating the thickness loss, we use the formula given here, and for the density, only for the density, the formula changes for the density. For the bare steel, we use 7.86, while for the density of hot-dip galvanized, we use 7.13. So now for the result and discussion. For firstly, this one is the appearance of steel structure, steel specimens after exposing it, the unexposed 3 months and 6 months, and this is for SS400 for all three stations. From this overview or from this appearance, we are able to make a judgment that both SS400 and SM490, if they are bare steel, they get corroded. When we compare station 1 and station 14, station 1 has a very much lesser corrosion product on it compared to station 1, station 14. This is because this is due to the difference in the exposure time, because the station 14 was exposed in March while the station 1 was exposed in June. So due to that difference, there is like the difference in the corrosion product as well. And if you see the pictures clearly, we see that in 3 months the specimens has a reddish yellow orange rust, while after 6 months it changes to brown. And in the hot-dip galvanized, they do not have any rust production, and after 6 months there has been a white rust on some of the specimens. And for the comparison between bare steel and hot-dip galvanized, we can say that hot-dip galvanized can withstand the corrosion without any problem till 6 months. And now for the thickness loss, we use the equation that we have shown in the above slide, and then we calculate the corrosion rate. We have both bare steel and hot-dip galvanized in the graphs, and then from the figures we are able to know that the bare steel has more thickness loss compared to hot-dip galvanized. And when we compare the two types of steel structure, SS400 and SM490 has a higher thickness loss. That is due to the chemical composition, because of the presence of more copper present in SS400. And while comparing station 1 and 14, 14 has more thickness loss compared to station 1, even though they are in the same province. It is because of the different time of exposure, as 14 was exposed in March while station 1 was exposed in June. And when we compare station 13 and 14, since they are exposed at the same time, we notice that the thickness loss for station 14 is more. This is because it is much closer to the sea, and when we compare the rate of corrosion for 3 months and 6 months, we notice that the rate of corrosion for 6 months is lesser. This is because the rust formed during 3 months act as a barrier for the rust that are meant to be formed after that. And then the thickness loss for hot dip galvanized is very minimal. This is because the exposed layer is only zinc and the steel structure remains totally safe. Now for the environmental data, from the environmental data we collect the temperature, rainfall, and relative humidity, and and humidity. And for a climatic condition to be a corrosive environment, it needs a high temperature, high relative humidity, and a little rainfall. And if it has a very heavy rainfall, for example, for station 1, it has lesser thickness loss compared to the other two stations because in June, July, August, they have heavy rainfall, and therefore it is hard for corrosion to take place as there is not enough sunlight for it to for the temperature, as the temperature is always low. And for the climatic conditions, and this let us know that the corrosion is affected by temperature, humidity, and rainfall. Now moving on to conclusion. So hot dip galvanized is a very effective way to minimize the rate of corrosion because uh, when we calculate the thickness loss, we can see that the thickness loss is very low compared to the rate of corrosion of bare steel, and it is lowered around 30 times, which means that we are able to protect the steel 30 times better. And uh, we know that environment plays a very huge role in the corrosion of steel because even if the stations are like together but a little bit different, the rate of corrosion is different. And also uh, that if we in this research, if we have considered more parameters such as chloride and sulfur dioxide, it would have been more accurate because it is in a marine industrialized area, as but we haven't considered it. And for from the main point of view, from the main uh, research, we can conclude that hot dip galvanized is very effective way to reduce the rate of corrosion, and for uncoated steel is very susceptible to an atmospheric environment in Thailand. And now, uh, and now this is the reference, and thank you for listening.